Hi, everyone. Welcome back to some more book learning. All right, so we are going to take a look at working with scientific notation here and being able to convert from a number to scientific notation and back again. Basically, it's a bedmas problem, but there are some tricks. So it's up to you if you want to use tricks or if you want to use bedmas, but you should be comfortable with doing both, or certainly see the relationship with both at this level in your math education. You want to understand why, not just how. You want to be able to know why it's working. That way you can apply that knowledge to other situations. And there's less to memorize. If you only memorize all the hows, then you have to memorize so many things. If you remember the whys, there's very few rules in math that we're following. Bedmas is a big one. So let's take a look here. 3.2 times 10 to the 4. This is what this means if I expand this out. First, I'm going to write it out. 3.2 times 10 to the 4. And then I use an equal sign to say what's on top is equal to what's on bottom. 3.2 times 10 times 10 times 10 times 10. There's this really cool thing about multiplying by 10 in our number system. All it does is move the decimal place. Here I would move the decimal place once, twice, 3, 4 times to make the number bigger, because multiplying by 10 makes something 10 times bigger. Watch this. If I have $100 and I find a really great investment that will increase my money by tenfold, then I would get $1,000 from $100 investment. An increase by 10. I multiply by 10. Okay, so but those types of investments, be very suspicious of them. That's too good. Okay, all right. So now 3.2 times 10 times 10 times 10. I could write this as 3.2 times 1 with 1, 2, 3, 4 zeros. That's also multiplying by 10, as you can just count the number as tens and then put the zeros together with a single one. That's actually true. This is the same as that. Then I can say, well, 3.2 times that. If I multiply this in, the 1 is 3, 2, 0, 0, 0. And then I check, okay? Many of you already knew about this trick here, where you say, this is a set of instructions that tells me to take this decimal place and move it once, twice, 3, 4 times. Let's check. The decimal place started there and it went once, twice, 3, 4 times. Very good. It is correct. Now let's take a look at another example. Oh, this one has a negative. What do I do? The negative exponent tells you to divide by that number that many times. The positive exponent tells you to multiply by that number that many times. So this is what we mean by a negative exponent. It means divide by 10 twice. Dividing by 10 has the same cool property with the decimal place in our number system, but it moves the decimal place the opposite direction. Okay, so here we write this one out. 6.5 times 10 to the negative 2. Okay, this is the same thing as saying take 6.5 and divide by 10 twice. Notice all the 10s came down there. Okay, and now that's equal to 6.5 over 100. So it's 6.5 hundredths. And we can write 6.5 hundredths in this way. 0.0. This is the tens. Here's the hundredths. So 6.5 of them is there. And actually, I don't want that decimal place. It doesn't make any sense to have two decimal places in one number. There we go. So that's that. Now some of you, fewer of you, recognized this rule, where this is a set of instructions that says move the decimal place, but move it in the opposite direction. So in that case, it would go whoop, whoop twice. That would be the new decimal. We'd add one in front just for clarity, 0.065. And that's what we got there by dividing by 100. If this is confusing, do it on a calculator, and after a while it won't get confusing. So that is correct. That's how we work with these two flavors. Now let's see if we can put this one and this one into scientific notation so that we can be sure that we've mastered this important topic. All right, so first of all, 12 million. First, let's write it out. 12, comma, 000, comma, 000. That is 12 million. Now, scientific notation always has the decimal to the right of one digit only. So I want to move the digit there. So let's count how many places we needed to move the decimal place. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So I will call this number 1.2 times 10 to the 7 because I moved the decimal place 7 times to get it in the correct place. And that's done. That's correct. And then this one, 0.0076. Running out of colors. Orange it is. This orange is better. All right, so 0.0076. I know that I need to move the decimal place. I am moving the decimal place this way once, twice, 3 times to get it after the first digit that's not a 0. It says 1, 2, 3. So I can call this number. Notice the way I use my equal sign. It equals 7.6 times 10 to the negative 3 because the decimal place was going that way. Okay, so that there is correct. So this is how we can convert numbers from scientific notation to standard notation. Standard notation is basically where I expand it out. Or, in other words, do the bedmas on this. First do the exponent and then multiply. Okay, so I hope this is helpful for you. Oh, and some of you are fueled by this negative. This means negative 9.8. This is how you would write a negative number. Let's expand this one before I check out and go make lunch for my family. I would write this as negative 980000. And why that many O's? Because 1, 2, 3, 4, 5. So this is a big negative number. And if we were evaluating from least to greatest, we're putting it on a number line, it's the least because big numbers negative are less than small numbers negative. Okay, further, oh wait, I'm mirrored further that way. Least, greatest, 0 in the middle. Okay, that's how it works. All right, I hope that is helpful. Any questions, hit me up by email. Bye for now, everyone.